Okay, as we look at this curve, we're asked to determine something about the first derivative and the second derivative. So let's go ahead and take the first derivative and the second derivative for each of these problems here. So the first derivative is 6x squared minus 6 times k plus 1x plus 6k. Now we need to remember that k is a constant number, so we don't have to use the product rule here. If we multiply this out, we get 6x squared minus 6kx minus 6x plus 6k. And we can take a 6 out of all of those, and we're left with x squared minus kx minus x plus k. That should be factorable. It's 4 terms, so we're going to group the first two together, take out an x and get x minus k, take a negative 1 out of the next two and get an x minus k, so that our final answer down here becomes 6x minus 1 x minus k. Well, set the derivative equal to 0, we get x equals 1 and x equals k. If we come down a little further and do a sign line to determine what's happening with the first derivative at those points, or in between these here, there's 1 and there's k, and we've got x minus 1 and x minus k. I'm not going to write the 6 because we know that it's positive all the time. We know if we put a number smaller than 1, this is going to be negative, this will be positive, this will be positive. Now, how do we know that k is to the right of 1? If you go back to the original problem, we were told that k is greater than 1. So if we put a 0 in here, that's going to be a negative number. If we put a number smaller than k in here, it's still going to be negative, and larger than k will be positive. So it looks like that the first derivative is negative between 1 and k. If we go back up here, we were asked to find something out about on the interval 1 to k, and y prime is negative on these two intervals. So it's one of those two now. We just need to figure out something about the second derivative. So let's go back and determine the second derivative. If we go back and take the second derivative of this thing, it will be 12x minus 6 times k plus 1. Well, when is that equal to 0? We're solving for x. So if we take that over, we get 12x equals 6 times k plus 1. And if we divide that out, we get x equals k plus 1 over 2. So now we need to look at a sign line for the second derivative. And always try to label your sign lines so you don't get them confused here. And we've only got one point on here, but that could be a hard point for everyone to talk about and figure out what's going on here. So I'm only going to have the one factor, so maybe this will be a little bit easier to talk about. Now remember, k is bigger than 1, so if we take a number bigger than 1 and add 1 to it and then divide by 2, we're going to get a number bigger than 1 here. So we know this number is still bigger than 1, so let's use something smaller than 1. What if we put 1 in here? Or what if we put 0 in for x? Well, we know that 12x would become 0, and k is already a positive number. Add 1 to it, it's still positive, but multiply it by negative 6, so it's a negative number. That tells us that the second derivative is decreasing at this area. So leads us to believe that one of our two answers are correct up here, namely the one that says the first is negative and then it's positive. So that's what we're going to go with for the moment, but let's go back and look at something else here. What if we put something bigger than k in there, k plus 1? What if we put 2k in there? Well, then we would have 12 times 2k minus 6k minus 6. Well, that would be 24k minus 6k, which is 18k, which we know k is positive, so this is a positive number minus 6. It's going to be positive. So the second derivative is increasing, So we are correct that the y prime is first negative, is negative all the time, and then second derivative is first negative and then positive.